Hello everyone, this is a video lecture for Pre-Calculus Chapter 7.2, Add and Subtract. Well, addition subtraction rules. So I'm going back to the trig identities, and in particular, we're looking at this sum and difference section right there. So add and subtract. I already wrote them out here again, so this is a little bit more clear, I suppose. There's tricks to trying to memorize some of this, and you might think, well, why do I have to memorize it? But, I mean, it's a good thing because it's definitely faster, and it helps you as you go through, you just recognize the form better. So with sine, you got sine, cosine, cosine, sine. With cosine, you got both cosines. Notice that it's changed the sign. It's not plus minus, it's minus plus. So if you had a plus here, now you have a minus. If you had a minus there, now you have a plus. So cosines, then sines. With tangent, it's just, you add them in the top and you multiply them in the bottom. Obviously a different sign there. I personally don't have them perfectly memorized, but by the time I'm done with Chapter 7, I do have them memorized again, but then I forget them in the next semester. So, I mean, it's a good thing to know, but I wouldn't say it's crucial, it's not critical, but it's definitely helpful, okay? So, 72006, they start with cosine of 165 degrees is equal to what? Now, let's just be straight here. Could I put that in a calculator to get a decimal? Yes. Are they going to accept that? No. Not as far as I think. I'm pretty sure they don't. But I'm going to assume they don't. We're going to be using these formulas in order to find the exact value of that. Now, here's another thing. Maybe you have a very fancy calculator and you put that in. Will you get the exact answer that they were looking for? Yes. Yes, it is possible to get that. I'm not going to assume you have that. We're instead focusing on how to do this math by hand. And again, this is for your benefit. Whenever you're moving on to calculus, you're going to be doing all this stuff by hand as well anyways. Calculator's going to just slow you down. So let's keep going. I want to use these formulas with this. Obviously, cosine. So we're going to be doing this guy. I need to rewrite this as u plus or minus v. And so there's a couple options that we have. Like, I could do 180 degrees minus, how do we get there? 35 degrees, right? Is it 35 or would it be 25? Hold on. This is not how you do it anyways. You're not going to get something you like anyways. Minus 15? Yeah, minus 15. There you go. Sorry. I was way off. Hey, but you're getting that lecture experience. 180 minus 15. Does this equal to 165? Well, yes. But, like, is that helpful to us? In a way, when I start writing this stuff out, do you know what the cosine or the sine is of 15 degrees? I don't. So that's not really a good one to choose. Like another silly one would be 164 plus 1 degree equals 165. That's silly because these are not helpful to us. They're not anything that I know. It's not ringing bells. Let me give you one that will work. Again, let's just say that I'm just trying something. What about 120 plus 45? Does that equal 165? Well, yes. Is this helpful to us? And I would say yes. These are both on the unit circle. And that's going to be my goal here, is to find numbers that are on the unit circle. Like here, let me just draw it on the side. 120 is somewhere over here on the unit circle, and 45 is exactly right here. Okay? Like sine and cosine and stuff like that, x and y values, we've got square root 2 over 2, square root 2 over 2. On this side, I have a negative 1/2 and a positive square root 3 over 2. So I have here all my points. I have my sine and cosine values, x's and y's. You know how that works. So let's actually do that. So I'm saying now, I actually have cosine of the 120 plus the 45. Well, if I'm going to write this out with that formula, it's cosine of the 120. That lecture experience, including the phone calls. Sorry about that. So, moving on. I'm rewriting this formula just like I had saw it up above. I'm going to get a little bit more room here. Notice that I have my cosines minus my sines. And I had a plus, now I have a minus. That should be following that formula, that format. Cosines, opposite sines. Okay. Do I know all of these values individually? And yes, I do. Remember that the cosines are x's and the sines are y. So the x value at 120, notice the x value right there, negative 1/2. Here, let me actually try to write it out a little bit clearer. The x value at 45 degrees, square root 2 over 2, minus sign. The y value at 120, square root 3 over 2. And then the y value at 45 degrees, square root 2 over 2. When I mush all this together, I get negative square root 2 over 4, and I get a negative square root 6 over 4. 3 times 2 is 6. I have a common denominator, so I could do this. There you go. So, that's the answer. If you were to go and get it wrong 3 times or whatever, see what their answer is, it would be this guy. That, at least something like it. They might switch the 6 and 2, but it would basically be this guy right here. There's no need to simplify anymore. There's nothing to simplify as far as I can tell. I wouldn't factor out a square root 2 or something like that. It's fine the way it is. Could you put this into WebAssign, and would it accept that? I think the answer is yes. I think it will. I don't ever try it because I think that simplifying it is also good. It's a tool. We should try to learn it a little bit, you know. Not just cater to one program, that is. So could you just type that in? Probably. But I'm not going to stop there personally, okay? I'm just showing you some, I guess, ways to approach this problem. Okay, let's do it again. And again. And again, and again, and again, and again. There's a lot of these problems. So, obviously I won't be doing them all, but, you know, I'm trying to get a good hand on what's going on. So they're saying, hey, rewrite this sine value here. And almost always they're going to be complicated. I mean, they're going to end up something like this. So, you know, be prepared for square root 6s and square root 2s over 4. Plus, minus, all over the place, who knows. This 43 pi over 12 is way outside of a single revolution. Notice if I went around one whole revolution, this is 2 pi. But another way to express that would be 24 pi over 12. Again, I'm trying to find that common denominator stuff. Notice that 43 is way past that. Of course, I had to zoom in while doing it, sorry. It's way past it. I don't know exactly where. It could be anywhere around here. So what I want to do is I basically want to say minus 2 pi to get it into a single revolution. And if I still don't have it good enough, then I can minus another 2 pi. So minus 2 pi here, again, I'm going to be using a common denominator at 24 pi over 12. And so essentially I'm just minusing the numerators. 43 minus the 24 is 19 pi over 12. Is that within one revolution? Is that within this amount? Yes. Notice that it's not 24. 24 is the full amount there. 19 is somewhere before 24, obviously. But I don't know exactly where. I'm not really caring too much right now. But this should be okay. So I'm going to, before anything, rewrite this as this guy. And now I can find out what's going on. So my new number is going to be 19 over 12. Okay. So I want to find a way to express 19 over 12 as something plus or minus something else, my u and my v. Again, I know that I'm going to be using these formulas up here, this formula right here. So what are the two numbers that will make that work? Again, there's a whole lot of options, but we're trying to find something that works on the unit circle. So I'm thinking of things that will add up to 19. So we got, well, 18 and 1, but I don't think that's going to help because remember that both of these are divided by 12. They all have a pi and all that stuff. Is 1/12 pi on your unit circle? No. So I'd say 18 plus 1 is no good. 17 plus 2, I mean, isn't that a prime number? 16 plus 3, that might work. Notice that I'm just trying numbers here. I don't know what's going to work. But these guys might simplify because, remember, everything's divided by 12, and I think they might cancel and simplify some. So let's just assume for a second we got 19 pi over 12 is equal to 16 pi over 12 plus 3 pi over 12. We're just going to try this out and see if it works, okay? This is a logical, good statement, but I want to simplify these and see if it works. So what can they cancel is a 4, leaving a 4 pi over 3. That sounds familiar. I think I've seen that on the unit circle. The 3 pi over 12, cancel a 3, you get 1 pi over 4. I think I've seen that before. So if you want to know the degree equivalent for these guys, 4 pi over 3, I'm trying to do the math here. I think it's 240. I think it's 240. I don't have a unit circle handy. I know that this guy's a 45 here. I think it's 240, 60 plus that. Yeah, I'm pretty sure about that. But we're not going that road. I'm just saying you can use that to find out where they are on the unit circle. So I'm going to go to unit circle, and I got this guy down here at 4 pi over 3. And then I got this guy over here at pi over 4. And I want to know what the points are. Again, this is the square root 2 over 2, square root 2 over 2. It's my x and my y, x and y, cosine and sine. So this is my cosine, this is my x, this is my sine, this is my y, whatever you need to call it. This guy over here is going to be the negative 1/2 and the negative square root 3 over 2. Okay? All right, so I have my number stuff ready. So now I finally am going to go back to what I'm going to write here. Here we go. My sine of the 19 pi over 12. Sorry about that. Is, sorry, it's a sine. Got distracted for a second there. Is, I'm supposing to be the 16 pi over 12 plus the 3 pi over 12, which we simplified to say that that would be, what was it, 4 pi over 3 plus pi over 4. Which should equal, now I'm finally going to that formula way at the top there, that we saw originally. Sine, cosine, retain your sign, sine retains the sign. There's a plus sign right there, you're going to get a plus sign here. And then cosine sine. See how I'm like doing memory tools, like the sine retains the sign, the sin retains the sign sign. Yeah. Let me just verify that I was doing that right. And sine, cosine, retain the sine, cosine, sine. Yeah. Okay, we're good. Cool. Well, now I want to replace these with my actual values, like these dudes right here. Okay, so sine, my y value at the 4 pi over 3 is negative square root 3 over 2. My cosine at 45 degrees, my x value, is the square root 2 over 2. Cosine of the 4 pi over 3 is a negative 1/2. And sine over here is the square root 2 over 2 again. Again, could that work in WebAssign? Probably. But I'm just going to give you the quick answer here. There you go. Cool. So I'm hoping that you're at least seeing that this is a tiny bit complicated. Notice that this that answer was the same as this answer. I think it was like identical. I mean, yeah, 2 and 6, 6 and 2, but they're both negative. You can actually swap them. This is a bit difficult, you know, but also you kind of know if you're going in the right direction because, well, either the unit circle is going to help you or it ain't. So that's how I kind of, you know, do this thing. 72011. So I've got now a tangent, you know, I got to do one of everything, of negative 11 pi over 12. So I want to rewrite this in terms of things that I know, and I'm having a negative to start with. That's kind of weird, isn't it? So maybe I have like a smaller number and a bigger number, or I don't know. How do I get an 11? So what if I had a negative... No. I got it. I'm sorry. I'm looking at my paper here now. It makes more sense. What if I had a 20 pi over 12 minus the 9 pi over 12. So would I get an 11? The answer is yes, but the problem is that it's negative here. I need a negative answer. And so how would I get this to a negative 11 if I change this to a negative and make that a positive? Or rather, I can rewrite it as, because it's got to be something minus or plus something else, 9 pi over 12 minus 20 pi over 12. Now I'm choosing those numbers because they simplify. So the 9 pi over 12, you can cancel a 3, so that would be a 3 pi over 4. And that's helpful. And then 20 and 12, you can cancel a 4, leaving 5 pi over 3. And both of those are unit circle. Let me go ahead and write that up. 3 pi over 4 is about right here. That's at 135 degrees. Okay. It's got a negative square root 2 over 2, comma, positive square root 2 over 2. That's my point there, my cosine and sine. 5 pi over 3 is like right down here. I think it's at 300 degrees. And so this would be a positive 1/2 and a negative square root 3 over 2. Now, I do not have a unit circle in front of me. I just want to tell you that I'm doing all this from memory. Not because I might mess it up, because, well, I might. But the point is you can do this too. You can memorize this unit circle. You might think, oh, man, I'm not going to be able to memorize this. Too many numbers. There's, like, tricks to it, you know? I don't know literally every single one. I just know quadrant 1, and then I just kind of repeat. Like this guy over here, he's like a 45-degree guy. Not 45%. 45 degrees. So I got my 45-degree stuff. This guy over here, he's a 30-degree. Or, I'm sorry, a 60-degree. He's actually one of these guys right here. So that's why I got the square root 3 over 2 in the front. Just saying. Okay. So the tangent formula is actually a little strange because they use tangent in both cases. So this would be tangent of 3 pi over 4. Retain that sign for a second. Tangent of 5 pi over 3. And then all divided by 1. And then you change its sign. Tangent of the 3 pi over 4 times tangent of the 5 pi over 3. Notice that we're multiplying those. It's a whole bunch of tangents. I don't have the tangent here. I've got my x, I got my y, I got my x, I got my y. How do I find my tangent? How do I find my slope? And what I need to do is basically it's y over x. That's my tangent. And so for this particular one, I guess I don't need an equal sign there. I'm going to say this one divided by that one. If you can notice, it's actually a negative 1. So that's going to be my tangent value that we're going to use. For this guy, again, my slope is y over x. The 2's are going to cancel, and negative square root 3 over 1, or just, well, I guess that's good enough there. And so I'm going to now be able to replace them here at these particular values. I plug those guys in, and here we go. So tangent at 3 pi over 4 is a negative 1. Tangent at this guy is a negative square root 3. And then I got a 1 plus, the negative 1 again, and the negative square root 3. Could you just put this into WebAssign? Yeah, probably. But let me just finish this off. 2 negatives make a positive here. And look how pretty that looks. Doesn't that look cool? No, I'm playing. It works in WebAssign, it does, but you know, if you get it wrong a couple times, they're going to give you something like really crazy. So let me show you. Well, actually, is it 2 minus square root 3? I don't know. I can't. I have it written here, but I think I actually did the problem wrong on my notes, honestly. But it would sometimes give you those kind of answers. You do not need to go that far. I don't care at all. You don't need to go that far. But notice that you're going to get something strange once in a while. I don't want to go there. Just notice that you don't have to do what they do. Okay? It's okay to get it wrong a couple times to see what they're doing. But sometimes it's almost deceptively simplified. It's deceptively simplified. The next one. Sine of 3 pi over 7 times the cosine of 2 pi over 21 minus cosine of the 3 pi over 7 and sine of the 2 pi over 21. and they want to simplify this guy. Well, isn't it backwards? Isn't it going backwards? Notice this format, sine, cosine, cosine, sine. This is saying it's the sine of this minus, because sine retains your sine, this minus that. Just like that. Well, we need a common denominator for this dude. If I do it a 3 over 3 right there, I'd have a 9. Let me go ahead and write the sign up to be proper. So 9 pi minus 2 pi all over 21. 9 minus to 2, it's going to be a 7. So now I've got 7 pi over 21. Those guys cancel a little bit. Make what, pi over 3? And that's 60 degrees, essentially. So sine of 60 degrees. I mean, that is, I'm straight up. This is unit circle. It's square root 3 over 2. And, well, you're done. Like, if you wanted to see where it is, it's like right here, again, at positive 1/2, and positive square root 3 over 2, and that's your y value. That's your sine value. That was it. 72054. So I've got now sine of the arc cosine of 3/4 minus arc tangent of 1/2. And they want to simplify this guy. Now, hold up. What's going on here? This is how I see this problem here. I see this as an angle and another angle. I'm going to call this one A and B. Like, if I were to rewrite this problem as sine of A minus B, is that less intimidating? I'd say so. So, is there a formula for this that I could just write it out? Yeah. It's sine A, cosine B. Sine retains the sine, cosine A, sine B. That was our formula from the very top again. This is going to be ultimately what I need to do to plug it in, okay? The thing is that I need to know more about this A and B stuff. Apparently my A's look really bad today. There you go. That's a lot better. So let's look at these individually. I just want to look at angle A for just a minute and see what's going on with this guy. Notice that my arc cosine is equal to that. I'm saying that whatever, I don't know, A is my angle, cosine of A is equal to 3/4. Right? Yeah. Yeah. Well, that's not on my unit circle. So this guy is actually really worthless to me. How do I then do it? Well, you construct a triangle. And this has been really old. I mean, this might even go back to chapter 5 for all I can't remember. Maybe chapter 6. But we're going to construct a triangle, and I'm just going to make a triangle up. There's my theta. And notice that I have a, I guess you can call this adjacent and hypotenuse. That's basically what's going on. So adjacent would be the 3. Hypotenuse is the 4. And could I find this guy over here? Sure. So I would do the Pythagorean theorem, 4 squared minus the 3 squared. So that's going to be 16 minus 9 is going to be square root of 7. Yeah, square root of 7. Okay. Do I know what theta is here? No clue at all. Don't even try to find it, though. I think it would take too much time to do that. So rather, construct a triangle, and we have this guy kind of like we're holding on to him. The other one that's going to be important is this guy, the arc tangent. So now let's look at B. This was A. Now we're looking at B. So that's going to say the tangent of B is equal to 1/2. Okay? Notice that I'm saying that B equals the arc tangent. Well, I moved the tangent over, so I got tangent B is equal to 1/2. It's just kind of like moving it in the correct place. Again, I don't see this on my unit circle. I know you're thinking, oh, well, I've seen a lot of 1/2s, but that's just an x value or a y value. That's not m. That's not your slope, right? So that doesn't work on the unit circle. So instead, I see this as opposite over adjacent. Opposite over adjacent. And so if I were to construct a triangle, oh, that's a B. I want to be proper here. Oh, I used theta on the last one. Okay, whatever then, theta. My opposite is a 1, my adjacent is a 2, and then this guy is going to be Pythagorean theorem, 1 squared, 2 squared. You can see square root 5 basically for my hypotenuse. That looks like a 22. That is not the case. That is 2 squared. Square root 5. Okay. So I have these 2 triangles. What am I supposed to do now? Well, let's go back to my answer here. I'm going to rewrite. This is my answer. This is my answer. I just need to, you know, put numbers to it. So I've got sine A cosine B minus cosine A sine B. Okay? Each one of these is a number coming from these 2 triangles here, somehow. So sine of A. Well, I go to A. Obviously, I'm going to go to A's triangle. Sine, if you remember, this is opposite over hypotenuse, right? Opposite over hypotenuse. Opposite over hypotenuse. So I would say square root 7 over 4. Okay. B. Oh, I go to B triangle. Okay. They want the cosine. Well, cosine, as you know, is adjacent over hypotenuse. Adjacent over hypotenuse. So 2 over the square root of 5. I'm like literally just plugging it in. Cosine at A? Well, it's kind of funny because we already have that, like, straight up. So I'm just going to say 3/4. Again, you could do the same thing as last time. And then sine of B is going to be opposite over hypotenuse. Opposite over the hypotenuse. 1 over the square root of 5. Okay. This should be good enough to type into WebAssign. You could simplify it a little bit. Notice that you have a common denominator. So I got 2 square root 7 minus 3 all over 4 square root of 5. I am happy with that. It should definitely take it. Sadly, the WebAssign really, really likes to simplify, and they went way extreme, and they gave me this guy right here. Their equivalent, I would not recommend going that far. It is not worth your time. Just stop. You're fine right here, okay? Cool. I guess next problem here. So here we go. I got 72055. So they have cosine of theta minus phi. So that's a theta. Let me write these up just so that you're all caught up here. And that's a phi. Phi. There's a lot of phis. There's like this kind of phi. There's this kind of phi. I don't know what kind of phi they're using. Just phi. Okay, so we have this guy here. Of course, I'm going to have a formula for this to expand it. That's going to be cosine of the theta, cosine of the phi. Again, change your sign. Sine of the theta, sine of the phi. Okay. So this is going to be my goal. Well, now what? There's no numbers. They give me some numbers. So here's all your numbers here, okay? We got cosine of theta is equal to 5 over 13. Theta is in quadrant 4. So that's totally awesome. Good information there. I also have tangent of phi is equal to the negative square root 3. And phi is supposed to be in quadrant 2. Okay. What? Like, seriously, what is going on here? How am I supposed to make this thing work? Well, it's difficult. This is a difficult problem. That's why we're kind of doing it together. I'm going to start constructing a triangle for each one of these, okay? Notice it says in quadrant 4. That actually is more helpful than you think. I'm going to construct a triangle thinking like it's in quadrant 4. This is my theta, by the way. You can do this as theta. Honestly, I'm going to just do this guy as theta. Cosine, if you remember, is adjacent over hypotenuse. Notice that it didn't give me the opposite. Well, then we can find the opposite, right? So the square root of 13 squared minus 5 squared. Is it a 12, I think? Pretty sure it's a 12. Yeah, 12. But the problem is that if you just put a 12 here, that's incorrect. This is in quadrant 4. That's actually a negative 12. That's a negative 12. Look, it went down, didn't it? It went down. Make sure you make the signs correct whenever you're doing this. Quadrant 2 for my next one. So let's try to find that one. And so I'm going to call this guy phi. Of course, like that thing is phi or whatever. It doesn't really matter. But notice that I have a negative for tangent. This is how I construct it. I say it's a tangent is y over x, opposite over adjacent. So my opposite is supposed to be a negative square root 3 and my adjacent is a 1? Well, hold on. This doesn't make sense. I'm going up, aren't I? Aren't I going up? This is not a good picture. It's still in quadrant 2, though. I know it's in quadrant 2, so how am I actually supposed to reconcile this thing? It's good enough. How am I supposed to reconcile this thing? Well, what if I were to rewrite it as positive square root 3 over negative 1? You see what I'm saying? Is that a negative x? Is that a positive y? Yeah. So now I can find my hypotenuse. I say the square root of, well, the square root of 3 squared plus 1 squared. 3 plus 1 is 4. Square root of 4 is a 2. So just 2. Okay. So, cool. I have my two triangles. Now what? I'm going to go back to my big formula right here. I'm just going to rewrite this guy. So I've got the cosine of theta, cosine of phi, plus, it's a plus sign now, right? Yeah, plus sign. Sine of the theta, sine of the phi. Remember that cosine, when I'm looking at theta here, these are all numbers. Cosine, when I'm looking up here, is going to be adjacent over hypotenuse. 5 over the 13. Cosine of phi is going to be adjacent over hypotenuse, negative 1 over 2. Sine is going to be opposite over hypotenuse, negative 12 over 13. And then sine of phi is opposite over hypotenuse, square root of 3 over 2. Notice that we have that common denominator of 26, so negative 5 minus 12 square root 3 all over 26. That is definitely good enough. I have one last question here. 72049. So, sine of the arctan of x minus the arctan of y. Sorry about that. What am I going to do with this? Like, how am I even going to start this problem? It doesn't have any numbers. So you're right. The answer actually is x's and y's. So this is a pretty crazy problem. And that's what I want to do with you. Again, I'm going to see this as an A and a B, okay? We've done this with the thetas and phis and the A's and the B's and whatever you want to call it. These are two separate things. And so in my answer, if you jump ahead, I got sine of A minus B. Therefore, it's sine of A, cosine of B, retain the sine, cosine of A, sine of B. This is my answer. I just need to, find out what's going on there. Let me construct a triangle for that first tangent. And if they don't say what quadrant it is in, guess what? I'm assuming this guy is in quadrant 1. I mean, unless they specify. So this is my A angle right here. Let me just put that A angle right there. Notice that this is supposed to be my slope. It's supposed to be opposite over adjacent. Opposite over adjacent. Now I know you're thinking, oh, but the x is supposed to go right there. No. Opposite over adjacent. So then this hypotenuse then ends up being 1 plus x squared. 1 squared plus x squared. You can't really simplify it. You just leave it as it is. Okay, so that's kind of like a formula. Again, I'm going to assume a quadrant 1 answer here, unless they tell me. Notice I got a y. It's the same thing. I got a y in my opposite. My adjacent's a 1. So I got this 1 plus the y squared for my hypotenuse. So I'm actually saying equal sign now, like this guy right here is equal to this. 1, 2, 3, 4. Oops, that's a minus sign. And I'm just going to fill it in. Sine of A is going to be opposite over hypotenuse. Cosine of B is going to be adjacent over hypotenuse. Cosine of A is again adjacent over hypotenuse. Make sure you're doing x's and y's in the correct order. And then sine of B is going to be opposite over hypotenuse. Awesome. Well, that should do it, but I'm going to go ahead and simplify a tiny bit, and I mean a very tiny bit. Okay, so that's 1. I'm going to multiply it by another dude, and like that's it. You could go further. I don't think you need to. There's no need for that. That's all I got. So overall, this is actually a fairly difficult section. It started easy, and then all of a sudden it got really tough and crazy. Take your time, go through this. If you got questions, ask me. But honestly, just break it down, construct your two triangles, use the unit circle if you can. And thank you. Have a great day.